Question 4. A test engineer wants to estimate the mean gas mileage, mu, in miles per gallon for a particular model of automobile. 11 of these cars are subjected to a road test, and the gas mileage is computed for each year. A dot plot of the 11 gas mileage values is roughly symmetrical and has no outliers. The mean and standard deviation of these values are 25.5 and 3.01 respectively. Assuming that these 11 automobiles can be considered a simple random sample of cars for this model, which of the following is the correct 95% confidence interval for the mean gas mileage? Well, we start with for means, it's always going to be your sample mean plus or minus your T star. Remember zap tags. So T goes with X bar. So we use T. Now, the standard error formula for one sample is the standard error or standard deviation divided by the square root of n. You can look that up, but it's always going to be standard deviation divided by square root of n. Now, what is n in this case? A dot plot of the 11 gas mileage. So n is 11. So we want that to be the square root of 11. So we really can only figure it out between these two, which one is going to be your answer, right? Our sample mean is 25.5. Our sample standard deviation is 3.01. We know that's going to be S. And that's your mean. So is it 2.201 or 2.228 as your T star? Now with T, we have a couple approaches. One approach, use the table. Your degree of freedom will be n minus 1. So let's look at our n. Our n was 11. So I'm going to go to 11 minus 1 and look at 10. And then I'm going to look at that 95% confidence level again. I think that was 95%. And I'm going to match the row and the column up. So if I match those up, I'll be at 2.228. So your T star is going to be 2.228 from the table. All right, let's say you want to use your calculator. I gotcha. Your calculator is going to do the following. You're going to go into your inverse T. Not inverse norm. Inverse norm is for Z. Inverse T is for critical values for T. So for your area, you're going to use parentheses 1 plus 0.95. Divide that by 2. And then your degree of freedom will be 10 because your sample size is 11. So we want to subtract from 1. And there's another way to get your 2.228. So we know the answer choice is going to be B. And you can see it a little bit more clearly with all that stuff here.